Hi guys, Mr. Canada here today, and we're looking at solving inequalities. So solving inequality is similar to solving equations, as I've aforementioned. It's 99% the same. The only thing we have to do is treat the inequality as an equal sign and put it back in at the end. As long as we aren't willy-nilly just kind of swapping our x's around, and we move them around through multiplication and not just moving them, like physically moving them like we've done previously, then we do not change the position or which direction our inequality is pointing. So if we just follow what we know from solving equations, it'll be nice and simple. To start us off, though, we're going to start with the simplest case, which is just addition and subtraction. I like to model those in one because it doesn't matter, it's just a reverse operator. Then we're going to work through what happens if there's multiplication next to a variable. Then we'll work with some division. Then fractional, which is just a combination of multiplication and division. Then we'll work on to some complex fraction, where we have combinations on both sides. Then we're going to look at just some combined problems. So just more combined problems, getting over to brackets, indices, and so on. So, instead of breaking these up into kind of how do we do each of these problems, well, we can't really talk about with solving equations because there's no one way to go through an equation. There's kind of guidance, but there's no one way. So that's why I say on every single one of these is our goal is to isolate x to its own side. So we want it in the form of x and then an inequality sign and then whatever else is on the other side we don't care about. We just want to know that x is related some way to all these numbers. Okay, so typically we do the reverse process, and I am going to try and introduce you to a new method of solving if you haven't seen it already, and that's working top to bottom. So even though we have an operator or an equal sign or unequal sign, which is inequalities, we're going to work down and have a second equal sign. This is very handy with solving because it allows us, if we've already have our stuff written, to add in bits of information. So here we want to solve the inequality x plus 3 is greater than 5 for x. So if we want to get x by itself, what do we have to do that left-hand side? So I'm just going to scratch out everything right there. If I was to make just that x plus 3, and I wanted to go and make x, what do I have to do? So there's only one thing I can do, really, is I can take away that 3, and then I'll be left with x. So how do I do that? Well, I actually said that. I say I take away that 3. So here, I'm going to subtract 3. And we're able to do that. We can do that when we're solving. However, there is kind of a clause. There is something we need to do. If we take away 3 from the left-hand side, we want to take away 3 from the right-hand side. So we have to have LHS equal to RHS. Okay? So we cannot change them. So we want to balance. This is called balancing, where we just do the same thing to one side, we do the other. So I'm going to try and work through all these solutions by showing that step in red. So here, my blue part here is just an equal sign, so I'm left with x, and line up your operator. Notice how it's in line, right? I could draw 2 straight lines, and I could find that it's in a column, right? Keep them one above the other. So all of my x's I kept there, my plus 3, minus 3, so that way you can kind of work down. So here we have x, and then this will just be 0, and this over here, 5 and minus 3 is 2. So if we take away kind of all these grid lines that I've drawn in, we have x, and we have, so that should be a plus 0, but that doesn't matter because 0 is just 0. X is greater than 2. Okay? And you can kind of see that if you just look even back at the question, and you could just say, okay, what value does, if I put in a value of 2, that would mean 5, it is equal to 5, right? But if we want something bigger, we just have to just say x is bigger than 2. So you're really just solving out for what value makes it the same, and then just saying, well, it has to be a greater than operator, has to be a less than, has to be a greater than equal, or less than or equal. Okay, so let's move on to example 2. So here, we want to keep x on this right-hand side and move this, get rid of this 5. So how do we get rid of this 5? Well, we have to take away 5. So we take away 5 on the left side as well. So once we do that, we can have our equal sign, and so we have 2 plus negative 5. Well, 2 add negative 5 is just negative 3. Then we have this less than. We have x, and 5 minus 5 is 0. So we have negative 3 is less than x. And we know that we can change that by x is greater than negative 3. Right? Because if negative 3 is less than x, x has to be bigger than negative 3. Like I said, this second way of rewriting it is really beneficial because it's hard to envision what negative 3 is less than x always means. Okay, let's get on to example 3. Here, we want x by itself, so we have x minus 3. So if we want to get rid of that minus 3, what do you have to do? Well, we have to add 3 to get rid of minus 3. So therefore, we have to add 3 onto our right-hand side. Following the same convention we're doing, have our equal sign, and then x minus 3 plus 3 is nothing. So less than 2 add 3 is 5. So x has to be less than 5. And one more example. Doing the exact same thing. So we want to get x by itself on this left-hand side here. So what are we going to do? If we have negative 4, we have to add 4 to get rid of it. Similarly, do the exact same thing onto our right side. Create our equal sign, and then just go column by column. X, negative 4, add 4 is nothing. We have our operator. Sorry, try that a little better. We have our operator, and negative 6 plus 4 is negative 2. So I always like rewriting it to the right just because it looks a little bit more clean. So notice one thing before I let you go and do some practice problems. Example 1, let's look at that. There's a negative 3 in red and a negative 3 in red on both left and right. Here there's a negative 5 and a negative 5 on the left and right in example 2. Example 3, there's a positive 3 in red and a positive 3 in red, both on left and right. And example 4, there's a positive 4 on the left, positive 4 on the right. So keep in mind, same exact thing. If it helps you do this in red pen, do it in red until you start to see, okay, this is what's happening every time. I'm doing one thing, same thing to both sides. And we're going to carry this same idea through when we do the multiplication, division, and every aspect of solving. Okay, so 5 questions for you to try. Pause the video now. When you're ready, press play, and we'll go through these questions. Okay, so welcome. I'm going to show all the subtractions on below the problems, and then I'm going to write my answers in on the right-hand side. So here, we have to take away 7, take away 7. Next one, I'm going to just work down. Here, I want to get rid of x, or keep x on that right side and get rid of that negative 9. What's the opposite of negative 9? Add 9. So we add 9 to the left. What's the opposite? We want to get x, keep x on our left, so we have to get rid of this negative 2. What's the opposite of minus 2? Add 2. So here, we have to add 2. Next one, we have x plus 4. What's the opposite of plusing 4? Taking it away. And lastly, we have negative 3 is minus x plus 2. Well, let's just keep that x there. I'm going to use this at the very end to show you a trick. Let's keep our x there even though it's negative. What's the opposite of plus 2? Minus 2. And so we get negative 2 on our left. So let's bring these together. Because now that we've done, that's basically all the hard work. Now it's just addition, subtraction. So I know we're just looking at our right hand side. So 3 and minus 7 is minus 4. And we have the next one. We have, 4 add 9 is 13. And less than, this will be x. And I always like to switch it around. So I say x is less than, x is greater than 13. Notice that it's, if you know the alligator crocodile kind of idea of doing these operators, it still looks like the x is getting eaten by the 13. Right. Next, we're adding 2. So here, we're just going to have x, and it's bigger than 1 plus 2, which is 3. Similarly, for our next one, we have x is less than negative 2, add negative 4. So we have negative 6. And this last one, so negative 3 and negative 2 is negative 5. And then we have our greater than, and then we have negative x. Well, this is great, but this kind of is introducing into my next topic of multiplication. Well, check out this, because we're not quite done. We want x, and we have negative x, right? So that's negative 1x. So we can just divide by negative 1 on both sides. And notice, we'll be left with 5, sorry, that should be in blue. We'll be left with negative 5 divided by negative 1, which is simply 5. And that's greater than negative x divided by negative 1 is x. So if they're both negative, you can just end up dropping the negative signs. And then lastly, we want to switch it around. So x is less than 5. So a little bit more effort to that last one.